Hi, I'm going to show you how to do a putting it all together graph. That's what I call it. We're graphing a rational function, a function that is written as a fraction, using limits. Step one, what I like to do is find what I call the points of interest. The points in which something funky is happening, because you'd be dividing by 0, which is the dangerous thing when you have fractions. So I'm going to set the denominator, which was x squared minus 11x plus 30. I'm going to set that equal to 0 to find out the weird spots on the graph. Well, that factors in x minus 5 and x minus 6, making the points of interest, or the x values that make that denominator 0, are positive 5 and positive 6. Because 5 minus 5 would make that one 0, and 6 minus 6 would make that one 0. So that's step one. Step two is I like to find out what is happening at those points of interest. Could it be a hole? Could it be a vertical asymptote? So what I do in step two is find the limit as x approaches both of those in the function. So it's limit as x approaches 5 in our function. When I plug in 5 for the top and the bottom, for all the x's, I get 0 over 0. I like to say that when you get 0 over 0, we can do a little math magic, because it's most likely going to be a hole. So what I'm going to do is recopy. I always like to remember to bring down that limit. I take out a GCF. One of my math tricks that I like to do is to factor. So I factored out a 5 from the top, and I was left with 5 times x minus 5. The bottom factors into x minus 5 and x minus 6. Cancel out the common factors, and I'm left with a simplified version of a rational expression as 5 over x minus 6. Then I'm going to plug it in. I'm going to plug a 5 in for the x. So I have 5 over 5 minus 6. 5 over negative 1 gives me negative 5. This means that I have a hole at 5, negative 5. And sometimes when I have a reduced, when I find that I can simplify a function, I like to write the reduced or simplified version at the top so I don't forget, because there's times where I would much rather use that shortened one than the long one. The other thing I'm going to do is I'm going to find out what's happening at 6, which was my other point of interest. I'm sliding off here. I plug that into the original. Again, my original was 5x minus 25 over x squared minus 11x plus 30. If I plug in 6, I have 5 times 6 minus 25 over 6 squared minus 11 times 6 plus 30. When I simplify all that, do all the calculations, I get 5 over 0, which means that this point of interest, x approaching 6 or at 6, creates what we call a vertical asymptote. Okay, next thing I'm going to do, step 3, is find out what's happening around that vertical asymptote. So step 3, make sure that is showing up here. Slide down here. Step 3, I want to find out what's happening at around 6. So I'm going to do the limit as x approaches 6 from the right. And I'm going to make sure I go back and use my reduced simplified one, just a little bit easier. So I'm going to substitute in a number very close to 6, but on the right side of it. So I'll have 5 over, let's say, 6.0001 minus 6. That gives me a positive number over a positive number, which means it's approaching infinity. Now I also want to find out what's happening as x approaches 6 on the left. 5 over x minus 6. On the left side of 6 would be, a good number might be 5.999. When I substitute in that number close to 6 but on the left, I end up with a positive number over a negative number, which means it will be approaching negative infinity. So those are my first 3 steps. My next step, step 4, is to find the horizontal asymptote. I'm going to slide up where I have a little bit more room on my paper up here for step 4. Step 4 is horizontal asymptote. To find that, I find the limit as x approaches infinity. I like, again, to use that shortened formula. So I have 5 over infinity minus 6. So that it is the small number of 5 over the huge number of infinity. In class, we like to say this means it has a big old but. It equals 0. So y equals 0 is my horizontal asymptote. The last step I like to do is find the y-intercept. So step 5 is the y-intercept. This is just a real easy point to plot that I think everybody should always have on the graph. For a y-intercept, it's where the x value is 0, so I can substitute that back in to either the long version or the simplified one. 5 over 0 minus 6 would be negative 5, 6. So let's see the information we have so far. I have a hole at 5, negative 5, vertical asymptote at x equals 6. On the right side of that vertical asymptote, it's approaching infinity. On the left side, it's approaching negative infinity. Horizontal asymptote at y equals 0, and that's my y-intercept. So I'm going to take this paper off and just look at my graph now and put that information on. We have a hole at 5, negative 5. Make sure that looks like a hole. I have a vertical asymptote at x equals 6. I have a horizontal asymptote at y equals 0. My y-intercept was 0, negative 5, 6, which is about there. On the right side of 6, so here's 6. On the right side, it was approaching infinity, so it's at the top. The left side, it was in negative infinity, which let's be honest, we know that because we have these points already here lined up for us to go through. And there's a quick graph of a rational function without a calculator.